Okay, so welcome to this ETP webinar. Thank you all for making the time to come along this afternoon. It is being recorded, so if you feel like you've missed anything, then it will be available after the fact to catch up on anything that you feel like you've missed. So I'm just going to share my screen. So hopefully that is coming through okay to you all. So my name's Alex Louden. I'm the Business Development Manager for the wind theme of ETP, and that role I do jointly with another organisation called the Offshore Renewable Energy Catapult. And this webinar, I'm going to take the opportunity to talk a little bit about ETP and some of the support that's available through ETP, and then go on to talk about some of the potential challenges and opportunities within the wind theme. So hopefully, after I've told you what kind of support we can provide, it might give you a little bit of inspiration as to what kind of projects might be possible through ETP. And then we're very fortunate to be joined by a company that I've done a lot of work with over the last few months called Technology for Advanced Offshore Solutions. And Martin is going to talk a little bit about his experience of undertaking the ETP project. And then lastly, we're going to have a question and answer session for any of you who would like to ask anything. And at that point, Syra, who's working in the background, will enable you all to come off mute and you can just ask questions verbally. So ETP at its core is an alliance of 13 Scottish universities who are all engaged in world-class energy-related research. And so most of the Scottish universities are part of ETP, and certainly all of those who have some kind of excellence in the energy space, whether that's wind, which I'm interested in, or any of the other kind of energy sectors that there are. And so ETP runs a suite of programs to support academia and industry. And one of those programs is called the Knowledge Exchange Network. And this is the program which is dedicated to helping small to medium enterprises, or SMEs, to develop new technology within the low carbon energy space. So it's a 3-year funding program for Scottish SMEs, running between April 2019 and March 2022. And it supports SMEs to access cutting edge energy related research and academics which are working within ETP's 13 universities. And so it kind of sits in this middle ground between industry and academia and helps to both increase the impact of academic research and supports industry to develop and commercialize new technologies and processes. And so Chem Projects, in essence, are low carbon projects, so developing a low carbon product or process which ultimately could be commercialized. And often it's the kind of first step on that kind of journey towards developing a commercial product or process. But sometimes those early exploratory steps are the most important when you're trying to understand the direction that a technology might need to go in. And any Scottish SME or SME with a strong Scottish presence is eligible for these grants. And so we can award grants of £10,000 for work by university academics. And we also do a more tailored version for PhD or MSc students to work on projects, which is up to £3,500. So typically that would pay for around 30 to 50 days worth of academic expertise to work on a company's technology development project. And it can be a real boost in terms of providing access to skills or expertise which isn't necessarily present within the company. And therefore it can really help to give an initial leg up in that technology development journey. And so Chem has 3 main aims, which are all quite interlinking, and it's all around supporting innovation through harnessing the expertise that exists within the ETP universities, particularly in support of the ongoing energy transition, which I'm sure you'll have all heard about, but in essence is this drive towards operating a net zero economy where we have no net impact on the climate system. And really all of this is geared towards trying to provide a positive economic impact for Scotland. So by helping companies to develop new products and processes and commercialise them, this is enabling them to grow and increase their contribution to the Scottish economy. And so whilst I focus on the wind theme, there are a range of people who carry out that same business development manager role within different energy themes. So if any of these are capturing your interest, don't hesitate to get in touch with any of us. And we all work very, very closely together. So we can easily signpost you amongst the BDMs to make sure that you end up in the right place. But all of the BDMs are located within some of the research institutes who are part of ETP, and some of us are shared with other organizations as well. So the BDMs cover themes from energy conversion and storage, energy distribution and infrastructure, energy efficiency in buildings, marine, heat, energy systems, and wind. And that brings in partners from the likes of Wave Energy Scotland, Construction Scotland Innovation Centre, Energy Systems Catapult, and the Offshore Renewable Energy Catapult, who I work for. And so that was a very, very high level introduction to the Chem programme. But I suppose what I want to spend a bit more time talking about is the kinds of projects which companies like those who you represent today might be interested in getting involved in. And this is by no means an exhaustive exploration of the types of projects which ETP could support, but I suppose it's an indication of some of the main challenges within the wind industry at the moment. So if you, as a company, are thinking about how your technology might fit into the sector, or whether some academic expertise might support you to make that leap, then please do get in touch, ask us questions at the end, or get in touch after the webinar, and we'd be happy to help explore how we might be able to support you on that endeavour. So first of all, I wanted to talk about some of the challenges within onshore wind. So whilst this is a relatively mature sector, there are still there's still lots of room for innovation and lots of areas which require new approaches and new expertise in order to solve challenges. And so I wanted to touch on three different areas of interest within onshore wind, fixed bottom offshore wind, and floating offshore wind, before we hear from Martin from Technology for Advanced Offshore Solutions. So firstly, I wanted to touch on the challenge around grid integration of wind farms. And this isn't unique to onshore wind. However, I think it's where the majority of the challenge is being faced first. And this is very much a multidisciplinary challenge because it overlaps with the kind of grid themes and energy systems as well. But as more and more renewable energy is added to the grid, how are we going to integrate it? And crucially, how can it support the grid in terms of providing ancillary services like frequency response or power available and things like that, which traditionally have come from gas power stations or coal power stations, which are easily ramped. Clearly, that's not possible with renewable energy, so we need to find new ways of delivering those services. And the more of those services that can be provided by sources like wind farms, the less we'll be reliant on fossil fuel power stations going forwards. The second topic of interest is another very broad one, which I've called wind farm optimization. And when, I guess intuitively, when you're thinking about a fossil fuel power station, clearly you want to make the most of every lump of coal or unit of gas that you have going in. because you're paying for every single bit of input into that system. For renewables, it's a bit different in that we're not paying for the wind. However, the more energy we can get out of every wind turbine, the cheaper overall the cost of energy is to the consumer, which is a crucially important aspect of our energy generation. So how do we capture as much energy from the wind as possible? How can we optimize the operations of wind turbines and make sure that they're running when the wind is blowing, and that services are carried out when maybe on a calmer day? Or how do we detect what inefficiencies there are within the system and then address those? So are there faults which are leading to inefficiencies which could be easily remedied and then lead to greater energy production? And then again, the last challenge that I wanted to mention in relation to onshore wind is not unique to onshore wind, but again, because that assets are a bit older than their offshore counterparts, it's certainly an issue that's facing more onshore wind farms, and that's of leading edge erosion. So when a wind turbine is rotating, the leading edge can be traveling at anything up to around 200 miles per hour. And at that speed, rain droplets act like a ballistic impact on the composite material. And as those vibrations kind of proliferate through the layers of the composite material, it can break away the layers and lead to quite significant erosion, like you can see in that picture in the bottom right. And as this builds up, it can reduce the aerodynamic efficiency and the amount of energy produced by wind turbines by up to 5%, which is quite a lot over the course of a period of time. And ultimately, this can lead to blade failures as well. So being able to accurately assess, inspect, and then ultimately repair this erosion is really, really crucial. And so there are opportunities to develop ways of either monitoring the health of those blades, or indeed developing new coatings and materials to carry out repairs. And there's some great research going on within some of the ETP universities on those subjects. So moving on to fixed bottom offshore wind farms. And in actual fact, all three of these challenges apply to floating offshore wind farms as well. So when I go on to talk about that, I've tried to pick specific challenges to floating offshore wind. But the first challenge I wanted to briefly mention is the reliability of the electrical infrastructure associated with wind farms. So clearly this is crucial for actually delivering the power generated to shore, and any faults will either reduce or completely remove the power being transmitted, which costs the site owner a huge amount of revenue because they're not being paid for electricity that isn't delivered to the grid. But also it costs the grid valuable electricity, which might be required to meet the demands. And so this is one of the most costly sources of failures. And in fact, it's kind of widely suggested that within the offshore wind industry, around about 80 to 90% of the insurance claims relate to cable failures, which highlights just how large an issue it is. So improving the reliability of these systems is really, really important. So there are definitely projects out there to explore how we can either monitor the status of these pieces of infrastructure, or indeed developing new technologies which are more resilient or more reliable. And that kind of links in with the second area of focus, condition monitoring. And one of the most costly aspects of operating an offshore wind farm is getting to it and going offshore, simply because it's a long way from the coast and chartering vessels is very, very expensive. And this means that the more that we can understand about the health of the assets without having to go and visit them, the more informed decisions we can make about maintaining them, which can lead to really dramatic cost reductions, because preventative remedies are significantly more cost effective than dealing with a component failure, particularly if it's a large component like an element of the powertrain. So what new techniques can we develop, or new sensors can we develop to monitor the health of these assets more continuously and more completely in order to better understand these machines which are operating offshore in quite a harsh environment. And then the last topic is a very, very large and very rapidly growing area, which is robotic maintenance technologies. So I've spent quite a lot of time over the last few years working on projects which are developing new robotic inspection and maintenance technologies. And one of the main drivers for this is really that offshore operations are costly and often hazardous. So the more operations which can be carried out using unmanned systems, the cheaper and safer the industry will become. And expertise can be deployed more effectively in onshore roles in better support of the sector. And so I guess the sort of future dream is that you'll have condition monitoring systems flagging to unmanned technologies to go out and carry out a given task, and that kind of quite automated process will be the way in which wind farms are operated, in 20 or 30 years' time. I think there's a long way to go before we get to that point, but there's a huge number of building blocks towards that vision which can be put in place now, developing the robotic systems and their applications within the sector. So making sure that they're capable of undertaking these tasks reliably and consistently. And so the last area I wanted to discuss is floating offshore wind, which is still a relatively young kind of subsector within the wind industry. However, it's widely regarded that it's going to grow very, very rapidly in the next decade and beyond. It unlocks areas with deeper water, which potentially have much higher wind speeds. And so the energy generation potential from floating offshore wind is enormous. But as a relatively young subsector, there are some significant innovation challenges which provide huge opportunities for SMEs to develop and commercialize new technologies. So for example, at the moment, there are a number of competing floating substations or floating foundations out there. And there's been very little consolidation as to what the best design might be. And I think ultimately there will be different designs which are better suited to different sea conditions or water depths. But there's a lot of room for optimization of these foundations, as well as the mooring systems which they deploy to keep them attached to the seabed. So there's been a number of SMEs who have been quite successful in developing technologies in this area. Secondly, when it comes to floating offshore wind, there's an opportunity for different strategies in terms of maintaining these assets compared to what is currently done within fixed bottom wind. For example, as I mentioned on the previous slide, it's very expensive to carry out offshore operations. So would it end up being cheaper to tow floating offshore wind farms to a port and carry out service activities there rather than doing them offshore? I honestly don't know the answer to that question, but there's a lot of room for optimizing the floating offshore wind operations specifically for floating offshore wind, as opposed to just directly lifting fixed bottom offshore wind strategies. And then lastly, one of the main differences in terms of the electrical side of things in terms of floating offshore wind is the move from a static cable, which is just comes out the bottom of the wind turbine foundation and is buried along the seabed, to a dynamic cable, which has to be capable of withstanding a lot more mechanical stresses in the section where it's free floating in the water column, because the turbine itself will move around somewhat during operations. And that means that that's an extra type of loading, which those cables have to be capable of withstanding compared to more traditional cables. And this means that so far, we've not seen these in as higher power ratings, for example, compared to static cables. So there's a lot of room for improvement, both in terms of uprating the power of these systems through to bend protection systems and buoyancy modules in order to reduce the mechanical stresses on these turbines. So hopefully that has given you a little bit of inspiration, and I'd like to invite Martin to say a few words about the ETP projects which he's undertaken in collaboration with the University of Strathclyde, and hopefully that will give you some even further inspiration, and then we'll open the floor for a question and answer. So over to you, Martin.
Thanks, Alex. So I'm Martin Lumberg. I work for Technology for Advanced Offshore Solutions, and I've actually worked with Alex for more than 2 years now, and I've been on both sides of the ETP project, first starting off as a research associate in Strathclyde, and now heading our project from an industrial perspective, in which we are investigating different solutions for monitoring and inspecting offshore structures underwater. So basically what we are doing is we're investigating, or we are a small research and development office set up 2 years ago for, or under the ownership of a ship operator and owner that conducts most of the work in offshore wind farms. And our task is really to take existing ideas, develop new ideas, and test them and analyze them with a bit more advanced method than what we used to do in terms of numerical work and simulations. So currently we're working on some mooring systems that we're using to inspect the subsea structures of fixed bottom offshore wind turbines. And we are working on an ETP project where we are simulating that with the University of Strathclyde. That ETP project also includes a student project where the students are working on transferring the same idea onto floating offshore wind turbines so that we can develop our system and actually generate some data, some reports where we can show that the approach we are investigating is viable, and we can go out to our customers and propose our ideas and therefore strengthen our commercial aspects of our ideas. The ETP projects for us really, being a new company, they allowed us to get in touch with the academic experts in the relevant field. So we have been put in touch with Strathclyde University, which have a very large school of naval architecture and ocean engineering, which for us really allowed us to dive directly into technical aspects of our ideas, develop concepts and test them very rapidly at a very advantageous project setup, costs and effort for us as a company. So we have about 2 academics working on the normal project and 2 PhD students working on the ETP student project. And I think in terms of the resources that we have, in terms of human resources, in terms of software access, in terms of knowledge and support networks, we really had access to something that as a new company we wouldn't have had access to for many years until we actually grew a bit further and had some more industrial context where we would have relied on project by project base to actually expand our work and our research. So in that way, ETP was a great stepping stone for us, and the students have done really good work. We are now in the last 3 months of our project, for which we're running for 1 year, and the outputs so far are very good. We have actually gone a lot further than what we imagined in the beginning. The technical development of our numerical solution went a lot further than what we thought we could do, and basically we are expecting a detailed report of our methodology, some material that we can use for advertising, and also some scientific publications for the numerical methods that have been developed as part of this project. So overall, it was a very, very significant impact onto our business and also onto I think the students itself, because they were involved in an industry project which is actually applied within the next year onto the offshore wind market, and also the university itself and ETP. We have had a really good partnership. I think if that summarizes roughly what we have achieved.
That was a great summary, Martin. Yeah, and so I guess the big question is, do you think your ETP project has helped you to bring the mooring system for subsea inspections to market quicker than you would have been able to otherwise?
We've definitely already convinced the partners that we've trialed and narrowed the system in the first stage of development to go deeper, and they've already basically shown the outcomes from our initial studies to their customers, giving us a better foothold in the market and convincing more and more companies to actually follow our idea. which is a significant cost reduction really for subsea inspections compared to large offshore service operation vessels. So we have had impact within the first 3 months of our project, and now we're working on actually making that a lot larger and more significant.
That's terrific. And I guess one of the things that in terms of ETP projects is that they are often the kind of first stage in a journey. So I don't know if you want to mention your kind of plans for the next year in terms of R&D.
Yeah, like I mean, you're well aware of our efforts. We have actually prepared together with the Ore Catapult application for an Innovate UK project to take this, the outcomes from the ETP project even further and develop optimized versions of the materials, the methods, and the applications used to predict the forces and the motions in this mooring concept. So we hopefully can take this a bit further and really industrialize our application even more and take it even further. And the other point I wanted to actually, I just remembered, because I've been on both sides of the ETP project. So it's also for the people at university. I think it's a great opportunity to get in touch with companies that are developing new solutions and also at a relatively small size, so where your work can actually have some impact.
Oh, that's brilliant. Well, thank you very much for sharing that. And would you be happy if any of the attendees have any questions during the Q&A session to answer them?
Of course.
Grand. Well, in that case, I'll open it up to those of you who have joined the webinar this afternoon. And does anybody have any questions? I think you should be able to bring yourself off mute if you would like to answer a question, or feel free to put it in the chat if you're more comfortable with that.
Yeah, hi Alex. It's Patrick McCarthy, Edinburgh and Napier University.
Hi Patrick.
Haven't seen you for a long time.
I know it's been a while.
It has. It's I don't know what happened to the year. I seem to have sat at this desk for some time and not done too much. So Edinburgh Napier is trying to become more research intensive. What it has lacked is business development capacity for some years, and consequently it really lacks contacts. It's also got kind of strange setup in that it regards what you do in relation with companies and universities as research projects, whereas previously I've looked at it as a business development function, if that makes sense. So what I'm trying to say is I don't see what you send out, and I suppose I'm saying contacts in this particular area, anything that you can send in this particular area in terms of challenges. I think it's really great what you showed in terms of challenges for the sector in those three slides or three screens. It's for us really good if we can get to understand, not just in wind, but in any areas that ETP is running. And we want to meet companies, and we rely on you guys as BDMs to push them our way, because we don't have the old Energy Academy opportunities that used to exist through excellent networking. That's
absolutely, Patrick. So I guess that's the part of the reason why we have the 7 BDMs working across 7 different energy themes. And actually, I think we're soon to be adding to that team as well. So what I would highly recommend is if you're interested in all 7 of those, have a chat to all 7 BDMs and get their inputs on each project, because we all spend on each theme, because we all spend a lot of time speaking to and working with SMEs and larger companies in some cases as well. So if you have particular interests, we might be able to hone it down quite quickly. One of the challenges is often if you're presented with, oh, we just want to speak to companies, it's such a big kind of question that sometimes a bit of specificity, if you've got particular academics working in particular areas, then all of us would be happy to have that discussion and find out whether we can link you up with some SMEs working in those areas to do ETP projects, or indeed to engage with other ETP programs like the PhD studentships.
Alex, thank you. It all makes sense. Just point people our direction.
Absolutely.
And to everybody else, don't need you to discriminate.
Any more questions from the floor? No, well, if there's no more questions, I guess, well, thank you very much for joining and listening to this webinar this afternoon. Thank you very much indeed, Martin, for taking time out of your schedule to come and share some of your experiences with ETP. That was much appreciated. Thank you very much. And yeah, please do get in touch. I'm sure that Syra will distribute the link to the recording afterwards, and I'm happy for you to get in touch via email with any questions that you may have following up from this. So thank you very much indeed, and enjoy the rest of your days.